Alzheimer's disease is unfortunately very widespread, and there are 4 million Americans right now who have Alzheimer's disease. And worldwide there's 25 million people. The economic impact is huge. More than $100 billion deficit to the American economy because of Alzheimer's disease. And of course the social impact is immeasurable. For those of us who are interested in what causes Alzheimer's disease, you know, the manifestations are memory loss. So you start to look for what's the mechanism responsible for that. And we all think that there are going to be toxins that build up in the brain of people with the disease, and those toxins are not present in the people who are aging normally and have just a comfortable change in their memory. But it turns out that that's actually one of the fundamental discoveries from our laboratory, is the discovery of a new toxin that shows up in the brains of people with Alzheimer's disease. And what that does is attack synapses that are associated with memory formation. It binds to those synapses, it attacks them, it makes them dysfunctional, and memory formation cannot take place. And what we, of course, want to do is block that from happening. And that's how we'll develop therapeutic drugs eventually. What about other diseases? Well, mad cow disease is a clear analog to this. And actually, Alzheimer's disease and mad cow disease, in principle, have very fundamentally similar pathology mechanisms. These are really the tip of the iceberg in terms of diseases that are based on a similar principle. A normal protein gets converted into an abnormal state. And there are at least 23 different diseases of this sort, including type 2 diabetes. You may have a way of detecting those readily and actually developing means to clear those toxic species based on assays such as these.